Let's solve problem 1, where we have been asked to find the value of this expression. So we can solve this problem by applying the distributive property. So we start with the given expression. And then we can write it like this. Now I will write it. And then I will apply the distributive property again. And then I can multiply. Now I will cross out these numbers, and also I can if I solve, I would get 1, and if I solve this number, I would also get plus 1. So the answer is then 2 for this problem. So the answer is A. Now let's look at problem 2, where we have a model that is used to estimate the time it will take to hike to the top of the mountain, and it is given in this form. And we are also given that the model, it estimates that it will take 69 minutes to hike to the top if a trail is 1.5 miles long and ascends 800 feet, as well as if a trail is 1.2 miles long and ascends 1100 feet. And we have to estimate how long it will take if trail is 4.2 miles long and ascends 4000 feet. So let's start with the model or the linear equation that is given. So we have time equal to AL plus BG, and we will start solving for A and B. First we need to find the constant or the parameters for this equation, and then we can find out for the given case. So if you see, we are given this information that the model, it estimates 69 minutes to hike to the top if 1.5 miles long and ascends 800 feet, and if it is 1.2 miles long and ascends 800 feet. So we can set up our two equations. So I would have then 69 is equal to A 1.5 plus B 800. So this is equation 1. Similarly, I can write the second equation, that is A would be multiplied with 1.2 plus B 1100, and this is equation 2. So now if you see, we have now two equations and we also have two unknowns. So we can solve them either by the elimination method or substitution method. But in this specific case, if we apply the elimination method or substitution method, the problem can get a bit long. And so in order to solve the time, it would be easier if you just subtract equation 2 from equation 1. Okay. So then on the left hand side, I would have 0 because these two numbers they will cancel out, and I would be left with 0.3a and minus 300b, right? And now I can rearrange to find the value of a in terms of b. So for that, I would get a equal to 300b over 0.3. So now I can write it like this: a is equal to 1000 b. And now what I have to do, I can plug this expression or this relation between a and b in equation 1. So if I do, then I would get 69 is equal to 1.5 to 1000 b plus 800 b. And then it is now 1500 b plus 800 b, and upon further solving I get 2300 b equal to 69, and so if you solve it, you would then get 3 over 100, right? Or you get 0.00 sorry, 0.03. Okay, so this is the value of b is. So to get a, just simply plug that back, and then a is equal to 3 over 100 multiplied by 1000. So then a is 30. Okay, so now we will put these parameters a and b in the general equation to find the time for the given case. So the linear equation that we have is and after plugging the values, we have 4.2, and we have 4000 feet the height. So if we solve it, then we would get 126 here, 120, and the answer is then 246 for this problem. So the answer is B. So let's look at problem 3, where we have to find the sum of the digits of the smallest prime that can be written as a sum of 5 distinct primes. So let's start with the first 5 primes and see what is the sum. So we have 2, 3, 5, 7, and 11. So if I add them, I get 18 and then 23, 26, and 28. But the number that I get, that is a even number. So it means that I have to take 2 out. I cannot consider 2 because otherwise it is not giving me a next odd number or a prime number. But I need a prime number. So in that means that I need an odd number as well. So next, let's try 13. So if I add now, I would get 24, 31, and if I add, I get then 39. So if I add them, as I say, like the answer is 39, but still 39 is not a prime. So then I would change 39. Sorry, I would change 13. So I cannot use 15. It's not a prime. So I would then try 17. So if I add now these numbers, I get then 28 and 7, 35, 40, and 43. So 43 is a prime. So if I add its digits, I get then 7. So the answer is then B for this problem. Okay, so now let's look at problem 4, where we are given that the number 2024 is written as the sum of not necessarily distinct two-digit numbers. What is the least number of two-digit numbers needed to write this sum? So for this problem, we need to be careful for two things. First is that the numbers, they cannot be distinct. And the second, that we have to tell the least number of two-digit numbers. So for such problems, we will maximize two-digit numbers. And then we'll see what is the remaining number that we need to in order to get the sum, for example, for 2024. So in other words, for 2024, we can write it as 20 times 99. So I'm basically maximizing the number of 99s here. And then I will simply add the remaining number that we need to get the sum equal to 2024, and that number is 44, and we need 1 times. So now the total number of two-digit numbers that we need, they are 20 plus 1. So the answer is then B for this problem. Now let's look at problem 5, where we have to find the least value of n such that n factorial is a multiple of 2024. So for such problems, first we will get the factorization of the given number. So I will see what are the prime factors for 2024. Now with 11, I can get to 23, and then I get 1. So the prime factors that I get for 2024, they are 2, 11, and 23. So now for n factorial to be divisible by 2024, it is required to have at least all of these prime factors with the same power as they are appearing in 2024. So therefore we need 23 appearing at least once, 11 and 2 should be appearing at least 3 times. So as we know, like 23 is a prime number. It can only appear if we have 23 factorial. So if I expand it, I would get then 23 multiplied by 22 multiplied by 21 and so on. So therefore the least value of n that we have, that we need, that is 23. So D is the answer for this problem. So now let's look at problem 6, where we are given that what is the minimum number of successive swaps or adjacent letters in the string A, B, C, D, E, F that are needed to change the string to F, E, D, C, B, A. So we are given this string A, B, C, D, E, F, and we have to change it to this form F, E, D, C, B, A. So we will swap one letter each time. So if we swap A first, so if we swap A to F, so we need to make total 5 swaps, right? And then the string we will get is B, C, D, E, F, A, and it will be after 5 swaps because we make one swap, 2, and similarly 5. So now we have this string, so we will now swap B to F. So for that we need to make now 4 swaps, right? So because we will make 1, 2, 3, and 4. So that would give us then C, D, E, F, B, A after 4 swaps. So similarly, if we continue, then the next time our number of swaps will reduce by 1, and we will have 3 swaps, then we have 2 swaps, and then we have 1 swap. So if we add this up, then the answer that we will get is 15. So D is the answer for this problem. Let's look at problem 7, where we are given that the product of 3 integers is 60. What is the least possible positive sum of the 3 integers? So let's assume that the 3 integers are x, y, z, and we know that the product is 60. So we have to find what is the least possible positive sum. So to ensure that the number that we are given, or the product is positive, we can have 2 numbers maximum as negative. We cannot have all 3 negatives because otherwise then the product will not be positive. So now we can start with combinations. Let's say that we start with 30. If we have 30 dot negative 2 dot negative 1, it gives us 60. So if I write the sum of these 3 numbers, the sum is 27. But now we need to see, like, can we have lower than this? So definitely we can have, but for that we need to use positive number, the smallest possible. So let's see what smallest possible we can have. So we can start with 10. For 10 we can have -3 dot -2. That is also equal to 60, and the sum is now 5. So now we can see like what other options we have. So we can have 10 -6 -1, that is 60, and the sum is now 3. So from here we can see like any other combination that we use, so that will give us a larger number. So then the smallest possible value that we can have is 3, and the answer is then B for this problem. Okay, so now let's look at problem 8, where we have that Amy, Bomani, Charlie, and Daria work in a chocolate factory. On Monday, Amy, Bumani, and Charlia started working at 1 p.m. and were able to pack 4, 3, and 3 packages, respectively, every 3 minutes. At some later time, Daria joined the group, and Daria was able to pack 5 packages every 4 minutes. Together, they finished packing 450 packages at exactly 2:45 p.m. At what time did Daria join the group? So there are 4 people who are working. We can label them as Amy, Bomani, Charlie, and Daria. And the first 3 they are packing at the rate of 3 minutes. So every 3 minutes. So they're having 4 over 3, 3 over 3, and 3 over 3. So basically 4 packages every 3 minutes. And Daria, he did packing at 5 packages every 4 minutes. So he did 5 packages every 4 minutes. So what we know that Amy, Pomani, and Charlie, they started at 1 p.m. and they finished at 2:45 p.m. So the total time that was taken by, I would write it like A, B, and C, is basically 2:45 p.m. minus 1 p.m. So that is actually 1 hour and 45 minutes, or equal to 105 minutes. So during this 105 minutes, the packing that they did, or the number of packages that they packed, we can find that. So like I said, then total packed by A, B, and C, that is equal to 105 divided by 3 and multiply by 4 plus 3 plus 3, and that would be then equal to 350. So they did packing for the 350 packages. So then packing by Daria, or the number of packages that Daria packed, that is equal to 450 minus 350, and that is equal to 100. And now we need to see that how long it take by Daria to do this complete packing. So I will say time taken by Daria. So that is equal to 100 multiplied by the rate. So she has, it would be then inverse. So it would be 4 over 5. So if I solve, I get 80 minutes. So now Daria took 80 minutes. So it means that she joined then 245 minus 80, and that would be then 125, right? Yeah, so it would be then 125. So then the answer is A for this problem. Okay, so let's look at problem 9, where we have in how many ways can 6 juniors and 6 seniors form 3 disjoint teams of 4 people, so that each team has 2 juniors and 2 seniors. So as given in the problem that we need to form 3 teams. So for the team 1, we have 6 seniors available and we are choosing 2 people from them. And similarly, we have for juniors, we have 6 juniors available, and then we are selecting 2 from them. So if we solve this, then for team 1, the number of ways that are possible are 225. So now let's look at for team 2. So for team 2 now we are left with 4 seniors and we are choosing 2 from them. And similarly we are left with 4 juniors and we are choosing 2. So now if I solve, I will get then 36. And for team 3, now only one option is left since there are only 2 juniors and 2 seniors left. So there is only one way. And the total ways is equal to 225.36.1, and we will divide it by 3 factorial because the order, it doesn't matter in this case. So then if we solve, the answer that we get is 1350. So the answer is B for this problem. Okay, so now let's look at problem 10, where we have that consider the following operation. Given a positive integer n, if n is a multiple of 3, then you replace n by 3. If n is not a multiple of 3, then you replace n by n plus 10. Then continue this process. So we have then asked that you start with n equal to 100 and what value results if you perform this operation exactly 100 times. So for such problems, we don't need to perform operation 100 times because it is very time consuming. So what we do, we basically find a pattern and then based on that we will find out the value. So the number that we start with is 100, and since it is not a multiple of 3, so I will then add 10 and add 10 again, and now I divide it by 3, add 10 again, add 10 again, now divide by 20, and then add again and it becomes 30. Now add 10 again, it becomes 40. Then if I add, sorry, here I should have divided by 3, so it becomes 10. And now if I add 10, it becomes 20, and it becomes 30, and then 10. So now if I see here, a pattern has started emerging. So if you see, we get 20, 30, 10, 20, 30, 10, right? So now if you see, after applying operations 1, 2, 3, 4, 5, 6, and 7 times, the pattern, it started emerging, right? So we had 30, and then if I apply this operation 3 times, now I'm getting 30 again. So the total number of times that we want to, or we are asked to apply the operation is 100. So 100 minus 7, I get 93, right? So after applying the 7 times in this operation, I get 30. So now after getting 30, if I apply this operation 3 times again, I get 30 again. And then this cycle, it continues. So, and the total operations that are left to apply after this 30 is 93. So if I divide 93 by 3, I get 31. So this loop, it will continue 31 times, and then it will end with the value of 30. So the answer for this question is 30. That is C.